Unreal Engine is widely known for using blueprints to visually code based on a concept of node-based interface. With this system, you can create virtually anything that you need to create, like a fully functional program or game. However, there are some systems that are difficult or impossible to access or code using blueprints. In these scenarios, you will have to dive into text-based coding in the form of C++. Some people say that blueprints are not as efficient as C++ coding. I was directly told at university you will need to convert all of your blueprint classes into C++ classes to keep your performance usable. I also see comments and questions often about using C++ over blueprints, even from my friends and colleagues. But how do they really know? Did they build a blueprint-based program that ran slow and redid the whole thing in C++ and it worked better? If so, was it actually due to the C++, or did they just write better code? I'm going to spend this video diving into some tests and see if C++ is really faster. I am well aware that I am putting a target on myself for debate and criticism. I can already foresee the comment section filling with, "You didn't test enough and your tests are irrelevant." I welcome the discussion. The point of this video is to test the systems and draw upon those results. If you don't agree with the testing methods, results, procedures, or anything else, tell me about it, and we could go deeper into testing in future videos. I will need to develop a test. The test should be as identical as possible between the blueprint and C++ code to ensure that both are doing the same amount of work. It should also be as simple as possible to reduce the margin of error. Finally, it needs to focus on a small intensive function to isolate the runtimes from everything else. I don't want to use bad coding practices to artificially slow the program down. I also don't want to use a test that spikes utilization. Ideally, I want to run a process that takes some time but not all at once. I don't want to cram 4 or 5 seconds worth of work into a single tick in a blueprint. The ideal test would be an entire game built twice, once entirely in blueprints and again entirely in C++. But this isn't very feasible for this video. Epic Games list advantages for each class. Some of these are not testable, like broader access, because by default the blueprints can't access some engine functionality, and therefore cannot be tested anyway. But they do claim that C++ is better at logic and math than blueprints. So I will focus on math logic. I will create a logic function that will run a few times per tick over a bunch of ticks. Something relatively simple that I can hopefully time very precisely. What I'm going to do is generate 100 random numbers between 0 and 1, and I'm going to sum those numbers and then divide by 100 to create an average. I will do this 1,000 times, once per tick. Then I will run that test 10 times and find the average time. I am going to build a rough idea of the program written outside of Unreal Engine in C++. I start with setting up the project and add some timer control functions to start and stop the timer. I'm going to need to keep track of the start and end times and the amount of time between them. I considered running a timer on a separate thread, but that isn't necessary because it isn't constantly checking the time during the test, just before and after the test has run. I can make a function to print the time that the timer ran for. Here, I make the nested loops that will run 100 loops 1,000 times and make an array that holds the random floats, and generate the random numbers. It really doesn't matter what numbers are created or the range, it's just work for the computer to do. Then I sum them up and average the results. Of course, it didn't work the first time. A good developer would have remembered to calculate the time duration. The test program seems to run correctly. Let's make it run 10 times and average those results. On my system, this simple program runs an average of 0.003 seconds outside of Unreal Engine. Let's do this again inside of Unreal Engine. We will need a way to see the results, so I will create a GUI using a widget display. I'll spend just a few minutes making it look nice. I'll go ahead and add a frames per second counter, mostly to make sure that the screen is working. Now, in the level blueprint, I'll add the GUI to the screen. Seems okay. Let's make sure we can see the mouse by setting the input to UI mode only and show mouse cursor. By default, the Unreal Engine editor frame limit is at 120 frames per second. I want to make sure that it doesn't limit in the final build, and I will remove the editor frame limit using a command line. In standalone mode, you can see that the frame limit is much higher. Now it's time to create the first test. I will start with the C++ class because it won the coin toss. I will create this as an actor class. I will also have the video go a bit slower so you guys can watch for mistakes or follow along. I really don't care for the live coding feature. I prefer to click the compile button myself when I need to. A quick compile test to make sure everything is built correctly. I will start with declaring a delegate so I can create some events when the test is complete. A good developer would have typed it in the correct place in the header file. Now I'll create the delegate event that we can bind in the GUI widget. Notice that there are error markers in the code, but Unreal Engine still compiles fine. This is a problem with Visual Studio. The easiest fix is to reload the files from Unreal Engine or restart the programs. I opted to just restart Visual Studio, and the errors are now gone. Let's plan this out with some comments. The idea is to mimic the rough draft I did earlier, but Unreal Engine requires a little bit of a different approach. I will create some variables, starting with a timer handle. Unreal Engine documentation recommends that we use timers and avoid coding logic in the tick event as much as possible. I also create a couple of arrays to store the random floats and the duration of each run to average later. I need a function to call if the timer expires or times out. This would be a failure. If this happens, I will send a notification event and handle that in the blueprint. I set the timer for 100 seconds, way longer than the work should take. I store the elapsed time using a function in the Timer Manager class and add it to the array of times. I move this work into functions to keep things tidy. I can now create the random numbers and add them to the array. 4 loops run within a single tick. This is the basis of my tests. The longer it takes to run this loop within a tick, the slower the game should run. I was going to attempt to run this in the begin play event, but realized that controlling the tick cycles would prove challenging. So I'll add a couple of run counters and move everything into the tick event. I add my loops and math work. Doing it this way should ensure that the 100 floats are created, added together, and averaged within a single tick. Once 1,000 ticks of work happens, it will stop the timer and not count any other work against the recorded time. I am sure that I am forgetting something, but I want to test the code in Unreal Engine. To use this code, I plan to spawn this actor when I click Start Test. In my widget switcher, I add a couple more screens for the active testing and results. I switch to the testing screen and spawn the C++ actor and print the run times. Naturally, it doesn't work. After some testing and poking around, I noticed a divide by zero warning in my log. There is a chance that the world delta time could be 0, and I need a check to avoid this in my FPS counter. I also forgot to make my widget screen focusable. I'll add a check to make sure that the world is available. I'll also change the timer to make sure that it isn't a looping timer. I will also add a world check to the stop timer function. And I forgot to clear the random float array before making new ones. I also forgot to reset the cycle counter. Without this, test runs 2 through 10 would never run. The problem all along. I was resetting the timer every tick. I need to check if the timer is running, and if it is, don't try starting it again. Now I am getting some recorded times, but I am not going to show them to you. I don't want to spoil the ending. After some very unnecessary checks that everything is running as expected, I'll start setting up the blueprint to retrieve the results and monitor the progress of testing. This is unimportant to the actual test, so I will move through this quickly. The progress bar seems to work. Time to build the blueprint side of the test. I will be recreating the C++ class as closely as I can in a blueprint actor. Again, the goal is to do the same amount of work in each tick for the same number of ticks. I start with the same timer type. This timer creates a handle and calls the attached event after the time value has expired. To avoid the same mistake I made in the C++ class, I'll check if the timer is already running and only start the timer if it isn't already. I want to verify that the timer is working correctly, so I set up the GUI blueprint to spawn the BP tests and print the timer timeout after 10 seconds. This seems to work. I will need the counters next to create the loops. Nope, I need to move this. Don't start the timer until I know the timer should be running within the 10 runs. Now the for loop for generating the floats and the counter for the 1000 cycles. Add the floats to the array and add each float value together. Finally, average the total and decrement the cycle counter. Now that the counter is at 0, having run 1,000 times, we need to read the timer and add it to the array to average later. Next, I reset the cycle counter and decrement the run counter. Since I already recorded the time, I can do this work to keep track of the progress without affecting the results. I don't need to broadcast every frame after the test is over, so I use a Boolean to flag once I notified the event after I average the recorded test times for each run. Time to bind the events and set everything up as close as I can to the C++ test. Small backtrack. I forgot to clear the timer handle. I think everything works. Working in blueprints feels so much faster. Blueprints were much easier to see and follow while I was looking for mistakes. Now to remove all the debugging, comment out all the log commands and make sure no logs are slowing things down. I will build out the GUI to display the results. Again, this isn't important to the test, so I will go through this quickly. I'm going to finish building the GUI. Also, I need to create a game mode so I don't spawn a player. I added a couple of delays to give garbage collection a chance to not interfere with the next test. I built out the results page and added another timer to time the total test time. I ran some tests and the results were not as I expected. There was never enough of a difference to make any claims. With a touch of research and math, I realized I wasn't loading up each tick enough, and I was running way too many ticks. The test was unnecessarily long and not doing enough work to slow the CPU down. As a result, these tests didn't truly stress the system enough to give accurate results. I changed the two tests to run 1,000 random floats for each tick for 100 ticks. This was 10 times more work each tick for a tenth as many ticks. I also read some additional things about frame limits that I wanted to test. I updated the GUI to allow me to change the frame rate limit within the program while running the test. I will share my final build of this test program for free on my Patreon page, link in the description. I will also share my complete Unreal Engine project for free to all member tiers of my Patreon. You can use this to alter or add tests, or have the ability to rerun the in-editor tests. Now that the test works properly, let's run the tests. First, I will run the program in the editor viewport at 120 frames per second. This resulted in the blueprint running 4 thousandths of a second slower, or 0.5% slower than C++. Next, the test was run at 60 frames per second. The results was blueprints running 2 100 thousandths of a second faster than C++. This can be considered equal. Now at 240 frames per second, the frame rate can't keep up with the background load. You can see that this is hovering around 140 frames per second. Here is where we see the first sign of the video claim. C++ ran 33% faster than blueprints, doing the exact same amount of work. Now I will turn the frame rate up to 1000, hopefully never capping the frame rate limit at any point. I received similar results as the last test, with C++ running 32% faster. Now I will do these tests again in the PIE window of Unreal Engine Editor. First, at 30 frames per second, with C++ running slightly faster, and at 60 and 120 frames per second, running virtually a tie. Again, at 240 and 1000 frames per second, when the frames per second can't reach the frame limit, we see C++ pull ahead by 15%. Now in standalone mode. Here I can add the NVIDIA Performance Overlay to show all the important data while running the tests. Remember, I'm recording my screen during these tests, so this affects CPU and GPU utilization. In these tests, 30, 60, 120, and 240 are all tied with C++ running the same as blueprints. It isn't until 400 frames per second that we start seeing C++ pull ahead by 5%. But in the 1000 frames per second tests, Blueprint fights back and pulls within 1%. Now the main event, the shipping build of the program. This is the version that the end user would be playing, so is usually the most important. 30, 60, 120, 350, and 400 are all within 1%, and at 1000 frames per second, the test ranges from C++ being 3% faster to 3% slower than blueprints. The variance from run to run seems to averaging out to C++ averaging about 1% faster. I'm going to repeat the shipping build test on a few different computers without recording software running. First is a moderately powerful laptop. You can see all the tests were very close to each other. Now I'll run the test on a potato of a laptop. This relic can only run the program at 2 to 3 frames per second. I debated not even doing this since the calculation showed that this will take over 11 minutes to test, but it's running, so I'll go ahead and wait. The results are super slow, but equally slow, being very close to each other. I was very surprised at all these results. Based on my test, the benefit of coding in C++ over blueprints is minimal. Only in the actual editor during development does there seem to be any measurable difference. Importantly, there's no difference in any of the machines that I ran the tests on in the actual shipping build. My analysis is that unless you are using very poor coding practices in the blueprints, they are equally as fast as C++. So if you are more comfortable coding in blueprints, use them. If you like C++, use that. I'd recommend that you eventually get comfortable in C++ due to the current limitations of blueprints, but performance-wise, there's no need to redo any work in C++ for the final shipping build. If you saw me make any mistakes or oversights, let me know. I'd like to eventually cover every corner of this debate and settle it once and for all. Remember, before you suggest a test, the test must be exactly equal in C++ and blueprints. If it's impossible to do in blueprints fully, it's not a fair test. I also don't want to build anything that changes the engine itself. The point of this is to run a program within the box version of Unreal Engine. Thanks for watching.